So, hello everyone, my name is Thiago Bomfim, and today we'll talk about how to stay on top of Java news from Java 8 to Java 19. So I have a lot of things to talk today. We'll start talking about Java 8, that it's an LTS version, and then we move to Java 9, 10, 11, and we go to Java 19, that is the last version, at least until now. And on the end, I will give you some bonus, okay, more things related with garbage collector, performance, and also some news of Java, some future of Java, okay? So let's start talking about Java 8, that it's an LTS version. But before we start, do you know what is the LTS version? The LTS version, it's long-term supported. This means that this version have a big support. And which version is LTS? Okay, we have 7, 8, 11, and 17. But if you are using 7, it's not support anymore, okay? So you probably need to upgrade your project, your version of your project, or maybe create a new project because your project is a legacy one, okay? I hope that you are able to update the version. And this is another important thing, okay? We have the version 8 that have the biggest extent support, that it's December 2030. But on the next year, we'll have the next LTS version, that it's 21, that will be the biggest extent support, that it will be September 2031. So be aware of it, okay? You should try to keep updated, but we'll talk about that in the next slides. But before we go to the news, let's talk about Java 8, because I know that most of you are using Java 8 or are using some things that is done in Java 8. Java 8 is a really big version, okay? We will not talk about everything in Java 8 because it will take at least 1 hour. So I'll bring just some features, okay? The first one, it's lambda expressions and virtual extension methods done by JEP 126. I will show you some JEPs. And what is a JEP? JEP is a JDK enhancement proposal. Usually, big things are done by JEP, okay? I will show you some JEPs if you want to search more about it, but not everything is done by JEP, okay? And what is that? What is the JEP 126? Basically, Java supports a sequence of operations that can be executed in parallel or sequential and with lazy execution. And this is very important because it's done by lazy execution. Let's see one example. So here we have an example that we have .stream, then .filter, then .map to int, and then .sum. .sum, it's a finalize method. So if you don't call the .sum method, the others methods will not be executed. This is why it is lazy, okay? This brings a lot of power for the developers, and also, at least in my opinion, it's easier to read and to understand. So this is a very important thing that you probably should know. And if you're using Stream, you also should know about functional interface. And what is functional interface? So yeah, we have a lot of functional interface, and I will show you how to create a functional interface and exactly what is a functional interface. But we have some of already functional interface created, like consumer, function, predicate, and supplier. And you should know them because if you are using Stream use functional interface. So if you don't know functional interface, you probably don't know very well the Stream, okay? For example, if you are using for each receives a consumer. And why or what is that? Basically, a consumer represents an operation that accepts a single input argument and returns no result, like for each that don't have any result. If you are using, for example, .map, you are using a function that represents a function that accepts one argument and produces a result. So usually when you use .map, we try to change our stream data. If you are using .filter, you are using the predicate. And what is predicate? Predicate represents a predicate Boolean valid function of one argument. And if you are using, for example, .collect receives more than one function interface, but it receives supplier. That represents a supplier of results. Okay, here are some of them. We have more, and you are also able to create your own functional interface. And how can you do that? It's simple. You just need to understand what is functional interface and do it. So basically, each functional interface has a single abstract method called the functional method for that functional interface. To it, the lambda expressions parameters and return types are methods or adapted. So here we have one example, okay, the parse toString that contains the method toString and receives an object and return a string. We also have this annotation that's very useful because this will verify if your interface have just a single abstract method, okay? Move on, we have another cool thing in Java 8 that it's optional. So optional is a container object which may or may not contain a non-null value. So if a value is present method will return true and get will return the value. Okay, so usually optional is used to avoid null pointer exception. So if your method can return null, you should use optional instead of return an object that can be null. Okay, so let's see one example. So here we have two examples. And do you know the difference between them, the or else and the or else get? If you know, if you don't know, put on the chat. Okay, yes, I don't know, something else. This is very important, okay, I will explain here. So what happens? Here we have on the first method, optional dot of knowable, and then the object, and then dot map, and then or else. So if our object is not null, we will execute the dot map method, and then we will execute the or else. Yes, if our object is not null, the or else will be always executed. Okay. Difference between the or else get. The or else get is a lazy execution. So for example, let's say that you have an object, and if you don't have this object, if it's null, you want to get the object from an external service. In this case, you should use or else get. Okay, so be careful with that. Okay, because in the first case, it's not lazy, it's always executed. And in the second case, it's just executed if the value is null. Okay, about Java 8, that. Now we'll talk about Java 9. I know there are much more things in Java 8, but we don't have a lot of time. And like I said, Java 8, it's a really huge version that have a lot of things. So talking about Java 9, we have modules, and according to JSR 376, the key goals of modularization the Java SE platforms are reliable configuration, strong encapsulation, scalable Java platform, greater platform integrity, and improved performance. And I will show that some of these goals are being achieved in the new versions of Java. Okay, so you see that now have more performance, Java platform are being scalable, and we have more strong calculations, and yeah, you see as I will move on to the next slides. And two important keys about modules is that each module must explicitly state its dependence, and a key motivation of the module system is the strong encapsulation. Okay, so this is the keys of modules. And I will not show you examples because this is another big thing that you can just about that. So I will keep move on. Okay, we have this feature that it's immutable collections using the list.off, set.off, or map.off. So be careful. This is useful. For example, if you're creating a test or you just want to return a value for the client, but be careful because it's immutable collection. If you try to add an element or remove, you have an exception, okay? Another cool thing, it's the if present or else. So in some case where we have if present does something, and then we create our own method or actually else. So if you have the if is present and then else, you can change to use this method, if present or else, okay? And another very important thing, it's the G1 garbage collector. So if you are using Java 9 or a new version, probably okay, it depends, but probably your garbage collector is the G1, okay? So in Java 9, the G1 become the default garbage collector done by JEP 248, and basically limiting the garbage collect pause time is, in general, more important than maximizing throughput. So switching to a low pause collector, such as G1, should provide a better overall experience for most users than a throughput-oriented collector, such as the Parallel GC, which was currently default. Okay, so is that I have about Java 9. And just to, okay, I'm showing just some things that I think it's important to know and to be aware, and also features that probably will help you in your daily activities, okay? But we have a lot of things that it's impossible to talk about everything between Java 8 and 19 in just 1 hour. So I will show you some of them, and I think things that can help you, okay? Again, if you have any doubt, you can put on the chat or you can ask me, okay? So on Java 9, what we have on Java 10, sorry, what we have on Java 10. So in Java 10, we have immutable cop collections that it's like the last one, but now it's a cop, and also it's unmodifiable list, set, or map. So be careful, okay? Because if you try to add or remove, you have an exception. We also have var. Yes, var was introduced on Java 10, and var don't mean that Java is not a typed language. Java is still being a typed language. So var, we have some rules. So you cannot create an instance variable with var. You cannot use var as arguments. You cannot type null to a var variable. You also vars also cannot infer array list type, okay, the type between for a list or a collection, and it also cannot infer lambda expressions. So be aware of it. Var, it's very useful when you have a type and you don't want to create the type, so you create var because it's clear what is the type. And another important thing is that you can have variables called var. I don't recommend it, okay? Don't do that. But if you are working in a legacy project that have variables called var, and you are not sure if you will update the version because of that, go ahead. There is no problem, okay? You can do that because you do not have any problem with that. But be careful, don't create your variables called var. This is not good. Okay, about Java 10 is that. Now we'll talk about Java 11, that it's our second LTS version. So as I said, Java 11 is an LTS version and has extended support until September 2026. Also, Java 11 have new methods to file. So you have read string and write string. So probably you have already created the input stream and things like that to read string from a file or write string. So now with these methods, probably will be much easier to do the same thing. Okay. We also have new methods to string. Basically, we have the strip. So we have strip leading, strip trailing. And as you can see here, we have the variable called name, James Gosling, and we have some blanks and special characters. We have now that trim doesn't remove this blank and this special character on the right side. So you can use strip or strip leading or trailing that it will do it for you. Okay, it removes the blank and the special character. We also have predicate not. I like it. I prefer predicate not instead of the exclamation mark. So yeah, this is, you can do what you prefer. I prefer predicate not. I think it's easier to read and to understand. Okay, about Java 11 is that. Now let's move on to Java 12. Again, if you have any doubt, please put on the chat, ask me now, or ask me on the end of the presentation. So the first thing I have in Java 12, it's the compact number. So here, for example, let's say that you have a big number like 2000 and something, and you want to print it in a short style, okay? Like 2.69K. We can do that with this number format and with the style short. But we can also do it for a long style, okay? So in this case, it will be 1000. And in this case, with the locale US, if you change the locale for your country, it probably will change, I don't know, okay? It will depend. And okay, about Java 12 is that, of course, some versions, I don't have a lot of things to bring. And we also have a thing called preview, second preview, third preview. So in some case, I will bring you, for example, in this case, I will bring you the second preview. But of course, the first preview was done on the previous version, okay? And why I bring this on the second preview for you? Because the yield special variable, okay, special thing. I will explain what is the yield, but before that, let's talk about what is switch expressions. So basically, as you can see here, now with switch expressions, we can use arrow functions and like lambda expressions with switch. So for example, switch day, and we have a string, we can create a lot of case, and we don't have to create a lot of break and return. We don't have to create a method for that. Usually we create a method that have the return so that we don't need to create the break. Usually we do that. With that, with the switch expressions, we don't need to do that. It's much easier. And what is the yield? The yield is used on the default to yield the value. So basically it's like a break and return value. Okay, it's basically that. So, okay, so let's move on. But before that, I have a question here. So why does Java add functional programming? Maybe you are talking the lambda expression, Java 8 and things like that. Java don't bring exactly the functional programming, all the concepts, but Java tried to bring something like that because functional programming have a lot of benefits, okay? Have also drawbacks, but have a lot of benefits. And I think this is the reason why Java tried to bring the functional interface, functional programming to Java, okay? So it's done by functional interfaces, Lambda expressions and things like that. So this is the reason why you cannot have external variable and use it inside. Actually, you can do that. It's not very good, but you can do that, but you cannot change the value for the external variable inside a Lambda expression, okay? So for example, let's say that you have a variable called count, and you try to change this value inside a for each method. It's not possible, okay? I don't know if I answered your question. I will keep going. If not, please just ask another question, okay? I hope so. I hope I have answered. So let's talk about Java 14. So the first thing we have to talk in Java 14 is text blocks. Here also the second preview done by Java 368. And as you can see here, now it's easier to create an HTML, XML, SQL content because we don't have to do a lot of concatenations. So it's easier, it's much cleaner. We also have records, and records are very important. It also here on the preview done by Java 369. And records provide a compact syntax for declaring class that are transparent holders for shallowly immutable data. So as you can see here, we have public record user that has two variables, the int and then the ID and the password. And be aware that a record is, it's like a immutable, so it's final, okay? So you cannot have you cannot extend user. Another very important thing is pattern matching for instance of, actually not for instance of only, the pattern matching thing. You see that have more things related with pattern matching. In this case, it's for instance of. So using that, you don't need to do a lot of cast, okay? So if you have some instance of in your project, you probably have some cast or you are using pattern matching, probably, okay? So these are great feature. We also have the helpful null pointers exceptions done by Java 368. And what is that? Basically, it improves the usability null pointer exceptions generated by the JVM by describing precisely which variable was null. So in this case, we have a.b.c.i equal 99. And the exception we have cannot read field C because a.b is null. So now it's very easy to see that, okay, B is null. This is the reason why I cannot access or read the field C. So it's easier to see null pointer exceptions, to identify null pointer exceptions. But be careful, because if you are using a.b.c.i, you are probably you are not respecting the law of Demeter, but this is not the best moment to talk about it. So if you want to know more about it, ask me on the end or search about it, law of Demeter. Okay, I will keep moving. So okay, so now we'll talk about Java 15. Again, if you have any question, you can put on the chat or ask me on the end, okay? So okay, so about Java 15, we have the select class done by Java 360, and this is the preview, okay? So before select class, Java doesn't provide any fine-grained control over the inheritance. So select class solves this problem. Select class and interface restrict each other class or interface may extend or implement them. So if you have never heard about sealed class, probably it's not clean enough. I will show you an example. So here, for example, we have this public abstracted sealed class shape. And then we have the permits. So we have permit circle, rectangle, and square. And what this means? This means that circle, rectangle, and square must be final, sealed, or non-sealed class. And with that, we can guarantee all the inheritance, okay, about the class shape. So for example, if you have a switch expression or thing like that, with this sealed class, it much easier to, and also, if I'm not wrong, we now have already completions errors because of that. So for example, if you have switch expression, if you have a switch that use a sealed class and you create a new object, like for example, permits a new, I don't know, the square, and you don't have the square before, so you have a completion error because you need to have you have to cut the square in your switch expression, okay? And also, if you have more sealed class, you can keep doing the same thing. So you have here sealed class rectangle, and then you can have the permits transparent rectangle and filled rectangle, okay? And of course, we can use it with records. And as you can see here, records fit very well with sealed because records are already final. So yeah, records is a really great thing to use with sealed class. We also have the ZGC garbage collector, that it's a scalable low latency garbage collector done by JAP 377. And basically, ZGC is a scalable low latency garbage collector capable of handle heaps ranging from 80 megabytes to 16 terabytes in size with sub-millisecond pause times. If you know about garbage collectors and pause times and things like that, probably sub-milliseconds max pause time, it's an amazing thing for you because it's really, really a big thing, okay? I will show you some things related with performance on the next slides, but be aware that ZGC is growing a lot and probably it will become the default in the future. I'm not sure, but it seems to be the best one. So, okay, so now we'll talk about Java 16. So in Java 16, now we have some full support features. So be careful now. I show you a lot of things like records, pattern matching, and they are preview, okay? And what this mean? This means that you are able to use it, but it's not full supported product feature. So if you are using, be careful. At least if you are using a version that it's in a preview, okay? If the feature is in preview. In this case, if you are using 16, you can use records and pattern matching that because it's full supported product. But don't use Java 16 in production because it's not non-LTS version. Another great thing done by JAP 369, it's the migration to GitHub. So in this version, the code base was migrated to GitHub, and this is the link. So now it's easier to find the code, to search the code, to understand the code, and also see the issues and things like that. Maybe also create a pull request or things like that, contribute. Another important thing, it's the .list method. The .list method in Stream basically replace the collectors.list. Basically replace it. Not replace actually. Be careful with that. It helps a lot, but that .toList method it returns an immutable list. So you cannot change everywhere that is using the collectors.toList to just .toList. Because as you can see here, the implementation, it returns an unmodifiable list. What this mean? This means that if you return using the .toList and try to add or remove an element, you receive an exception. So be careful with that, okay? The .toList help a lot, it's cleaner, but be careful because you cannot change the list if you do that, okay? Okay, so now we'll talk about our latest version, the latest LTS version, sorry, that it's Java 17. And before that, again, if you have any doubt, please put on the chat or ask me or ask on the end. For Java 17, we have some news. So in Java 17, like I said, is an LTS version and has the extended support until September 2029. Okay. Also, the sealed class is fully supported product feature in Java 17. So in Java 17, you can use records, you can use pattern matching for instance of, and also sealed class. But I will show you now some features that it's in preview, so you should not use, at least not in production. So we have pattern matching for switch, okay? So you can use pattern matching for instance of on Java 17 in production, but for switch, I think it's not recommended, okay? Because it's a preview feature. So as you can see here, it's very useful, okay? I really like it because now you can have a switch that receives an object and then you can do that like case integer I, and then you already create the variable and then you can use it. So I think this is very clean and very useful. So yeah, we have this feature. Let's move on. Yes, Java 17 don't have a lot of things. Again, I just show you some of them, okay? I don't show everything. But yes, Java 17, it's not so big version. Why? Because in Java 17, we have everything done between Java 11 and 17, and it is released on Java 17 because Java 17 is the LTS version. But if you think just about the version don't have a lot of things. Have more things, but like I said, I just bring some of them. Let's talk about Java 18. In Java 18, we have the UTF-8 by default, done by JEP 400. So we start with JTK 18. UTF-8 is the default shortcut for the Java SE APIs. And the APIs that depend on the default shortcut behave consistently across all JTK implementations and independently of the user's operation system, locale, and configuration. So if you're using Java 18, I hope no, but if you're using now, UTF-8 is the default. We also have the deprecate finalization for removal done by JEP 421. I don't know if someone here have already used the object.finalize. If yes, please put on the chat yes, or yeah, please put yes if you have already used this method, because this is not very common, okay? But if you're using the finalize method, be careful because you should not do that. This is deprecated for removal, so this method will not exist anymore. And why? Because this method is not very safe, okay? So if you're using finalize, you should migrate to another approach, maybe try with resource and cleaners, okay? And yeah, about Java 18 is that. Now we'll talk about Java 19. And this is our latest version. So the first thing, now have records patterns done by JEP 405. So now we can do the instance of for records. And not just that, we can also do that. So here we have the record and the variables inside this record done by the instance of. So if the object have this instance, it will create these two variables for us. So have the same thing, okay, the same result, but it's done in a different way, okay? It's your choose. We also have the pattern matching for switch, and this is the third preview. Like I said, the pattern matching are getting bigger, and we have a lot of things related with pattern matching and a lot of improvements that can help you as a developer. So in this case, we have the case null for switch. So before that, we usually do if null, and then we do something. So now we have this case null. So before that, if you have the object in the switch and it is null, you have a null pointer exception. Now, if you have this case null, you do not have an exception. You have this, for example, system out println oops, okay? You have a catch for that. But be careful, because if you don't create this case null, if you don't have that, you keep receiving a null pointer exception, okay? So you have to create this case null. And another very, very important thing, it's a virtual threads. This is the preview, and it's done by JEP 425. Please, again, put on the chat, yes, if you have already heard about virtual threads. So basically, virtual threads are lightweight threads that dramatically reduce the effort of writing, maintaining, and observing high-throughput concurrent applications. And yeah, virtual threads, it's not for everything or for everyone, okay? Now, with virtual threads, you don't need to change all your threads to use virtual threads, okay? You don't need to do that. But you need to be aware of it and understand it, because probably your framework will be using virtual threads, okay? Another way to use virtual threads maybe can help you. For example, if you are using microservice architecture and you are using an API composition, in this case, maybe virtual threads may fit well to deal with the parallel executions in an easy way. Okay? So let's see one example. In this example, we are not using virtual threads. We are using new cached thread pool. And in this case, I'm trying to create 100,000 threads. And it took something about 21 seconds, okay, if I'm using the processor count equal to. So I do the same with virtual threads. It took 3 seconds, something around 3 seconds. So yeah, it's much better, but be aware, in this case, I have 100,000 threads, okay? This is not maybe the usual for everyone or everything. So yeah, be careful. If you want to create 100,000 threads or 1 million, yeah, probably virtual threads will fit very well. And yeah, about Java between 8 and 19, it's that. Now it's the bonus part, and I will talk about garbage collector and the future of Java. Because now, if you realize that everything that I showed to you are useless, now I will give you another great reason why you should try to keep updated, okay? That it's performance. I will show to you how Java grow in performance, and it's really simple. just changing from Java 8 to Java 17, you have a huge impact in performance. But again, before I start, if you have any doubt, please feel free to ask. Otherwise, I will start showing. But before that, I also have a question. So please answer on the chat if you know. If you don't know, just put I don't know. Do you know what is the garbage collector in your project? Which garbage collector are you using? The parallel, the G1, the ZC, or another one like serial? I will talk now about some of them and the difference between them. But if you can answer on the chat which version are you using, I'll be glad. Also, if you know, if you don't know and you can, and if you want to put I don't know, I will also be glad. Okay, so the first thing we'll talk here, it's about footprint. And what is footprint? Footprint, it's basically the amount of space occupied by Java objects heap and Java class non-heap. Okay, it's basically that. And as you can see here, parallel have the fewer footprint. In this case, lower is better. So parallel comparing to the others is better. But as you can see here, if you're using Java 17, you have a small performance if you compare with JTK 8. Okay, so yeah, it's not a huge thing, but you have a small change. But if you are using the default that it's G1, you have a huge difference. Okay, as you can see here, I don't know, it's something like 4% or something like that. It's really big difference. In this image, I think it's easier to see the difference between them. So this is just G1, okay? So as you can see with Java 8, here we are using something around 6 gigabytes. And in JDK 17, it's something around 2 gigabytes. And with JDK 18, it's something around 1.5 gigabytes. And yeah, it's keep improving. Okay, so probably in Java 21 we have a really huge difference between performance from Java 8 and 21. So be aware of it. This is a great reason why you should migrate. I have more reasons I will show you later. Also throughput. But before we talk about throughput, what is that? So basically throughput represents the amount of work that can be done in a given unit time. So here it's different. The header is better in this case. And as you can see, the Java 17 is better in all of the cases. Okay, so one more reason why you should be updated. And the last thing that I will talk about performance is latency. These I think you already know. If you don't know, latency gives an indication of how long a single operation of the application takes. It's basically that. And again here, Java 17 have the best performance if you compare with latency. Okay, so yeah, and it's a really huge difference if you compare with JTK 8 and JTK 17. And about performance that, now I will talk about the future of Java. I'm seeing some answers here. Thank you, everyone. So, okay, so now let's talk a little bit about the future of Java. So we will have on the new version, the sequenced collections done by JEP 4.3.1. And then you have this method like add first, add last, get first, get last, remove first, and remove last. And I will also show you some projects like the Project Loom. What is the Project Loom? The Project Loom aims to drastically reduce the effort of writing, maintaining, and observing high throughput concurrent applications that make the best use of available hardware. And how is this being done? Is with these two JAPs, at least for now, that it's virtual threads and structured concurrence. These two things, it's very huge thing. It's very big thing. And these two JAPs are done by Java 19, but as you can see, they are preview and incubator. Okay, so there are a lot of things to keep growing, and Project Loom probably will help us help Java related with performance. Okay, we have another one that is Project Valhalla. Project Valhalla plans to augment the Java object model with value objects and user-defined primitives. So combining the abstractions of object-oriented programming with the performance characteristics of simple primitives. So I like this project. I like this name and also the project because it's amazing, this idea, okay, to try to have the performance characteristics of primitives combining with OOP. And this is being done by these JAPs and also the value object that it's a preview submitted draft. Okay, we don't have already a JAP for that, but have this primitive class done by JAP 401 and 402 that it's the class for the basic primitives. I will show you some links if you want to search more about it and also read about it. We have already things, but this is just preview candidate. Okay, it's not close to be ready for production. Another great that I showed to you, it's the Project Ember. The Project Ember, the goal of this project is to explore and incubate smaller, productive-oriented Java language features. So all these JAPs done by the Project Ember, I showed to you on this presentation, and all of them is related to help the productive-oriented Java language features. So probably these features will help you as a developer in your daily activities. The pattern matching for switch, the select class, the records, the pattern matching for instance of the text blocks, switch expressions, and also the local variable type inference, the var. And talking about the future, probably, okay, we don't have anything related with that yet, but probably in the future you have an unnamed class. So it will be possible to create a void main like this and do a hello world much easier and cleaner. So you don't need to write public twice and static and also method parameters. You don't need that, but this will be just for tests and things like that. It's just the hello world, okay? The unnamed class. And it's that. So let's recap what you see. So we see what you saw. We saw all these versions and also performance and the future of Java. And yeah, now I will show you some content where you can keep updated. But before that, if you have any doubt, please put on the chat. Otherwise, I have one that it's, should I migrate? So I think you probably have this question in mind. So the short answer is yes, but I know that it's not is. But why it is yes? Because if you migrate, you have more features, you have improvements, you have better performance, you have faster startup time, you have lower memory footprint, and you have another very important thing that is you are using frameworks, okay? And these frameworks are updating. Like if you are using, or if you want to use Spring Boot 3.0 or Spring Framework 6.0, you will need to have Java 17, okay? You have to update to the Java 17. So this is one reason, okay? Don't wait to your manager to say, oh, we need to change between Java 8 to Java 17 now because you have a vulnerability and you have to upgrade. Don't wait for that, okay? It's your responsibility to try to keep updated, okay? To bring this idea to update, don't wait to have a vulnerability or have some big issue and you have to update, okay? Try to keep update, go slow, it will be the best approach, okay? So again, this is where you can search more about it. So you have the OpenJDK release. We also have the Oracle documentation and the release notes. If you want to know more about the garbage collector progress from JDK 8 to 17, you have this link, this awesome article. If you want to know more things about Java 8 and to Java 18, you have this video, okay, on the Java channel. A lot of things that I don't show to you have in this video, and the same is true, okay? I also show something that it's not in this video, so this is a cool video if you want to keep updated. This is another one if you want to know more about the garbage collection, okay? This is a great video on the Java channel if you want to know more about the garbage collector and how it grows between Java 8 and Java 18. And if you want to search NJAP that I showed to you, you can use this link, okay? This presentation will be available on YouTube on the next days, so you can stop the video and get this link. This is my contact. If you have any doubt and you don't want to ask here, ask now, you can ask me here on the LinkedIn. And also, if you want to see some code or the code that I showed to you, you can access this GitHub, okay? Thiago Bomfim /Java news that have all the examples that I show here, okay? I don't know if